Hello and welcome to Analog IAS Academy. We know that Europe is experiencing extreme heat waves, scorching heats are there. And because of this extreme heat, they have created many health hazards there. Heat strokes are there. Many deaths have occurred. And in fact, it is also making the vegetation to dry there. And this dry vegetation is having potential to catch fires. And it is also creating a threat like drought-like conditions in many European countries. Now, one of the strong reasons for this heat waves is something called as heat domes. Now, in this session, we'll try to understand what is these heat domes, what meteorological phenomena are associated with heat domes, what triggers the heat domes, and also the impact of climate change on the heat domes. Now, to begin with, heat domes are referred as high pressure systems or anticyclonic type of pressure systems. And this heat domes is a natural meteorological phenomenon. And these heat domes are always associated with the period of warm temperature. And these heat domes are also associated with the role of atmospheric phenomenon called as jet streams. So hence, when we are talking about the heat domes, you should remember that it is a high pressure lid which is developed above the earth, and this high pressure lid is such that it do not allow the air to move out of that lid. It acts like a cap. And this warm air which enters into that lid or that trap reaches to the trough and it gets compressed and it again subsides downward. Now we know that in geography, any air, when it gets compressed and when it descends down, it is adiabatically heated and it increases the temperature of that trapped air. And this temperature which is increased is something which is creating extreme heat waves in the European countries. And many European countries are experiencing such types of phenomenon. And hence we say that these heat domes are natural phenomenon associated with certain types of meteorological part and linked with the role of jet stream. And often they are associated with the warm temperature. Now, how these heat domes are developed, or what is the meteorological phenomenon associated with that? We all know that the Earth's atmospheric circulation is referred as tri-meridional atmospheric circulation. It means that it develops three cells, and we refer them as the Hadley cell, Ferrel cell, and the polar cell. And when you talk about these cells, the boundaries of these cells have a geostrophic wind. And this geostrophic wind is referred as the jet stream. Now, in a simple way, when you talk about any jet streams, so jet streams are geostrophical winds which flows parallel to the isobars, where they maintain the balance between pressure gradient force and the Coriolis force. So hence, they travel parallel to the isobars. And when you talk about the jet streams, there are two permanent jet streams which are associated with the Earth's tri-meridional circulation. The jet stream which is there between the Hadley cell and Ferrel cell, we refer that as subtropical jet stream. And the jet stream which is between the Ferrel cell and the polar cell is referred as the polar front. And this polar front jet stream is associated with the event called as the heat domes. Now, the strength of jet stream or the weakness of jet stream depends on the temperature difference between the two cells there. Now, if the temperature difference is high, then these jet streams, they behave very strong, and the strong jet stream tend to move in a straight line. If the temperature difference between the two cells, that is Hadley cell and Ferrel cell, is high, then the subtropical jet stream will be strong. In the same way, if the temperature difference between the Ferrel cell and polar cell is more, then the polar front jet stream will be strong jet stream, which will travel in the straight line. But if the temperature difference between the two cells decreases, now here the problem starts. When it decreases, then the jet stream tend to become weak. And the moment when the jet stream starts behaving like weak one, then this jet stream starts developing the loops, that is the bends. And then the jet stream, when it develops pronounced loops, then instead of moving along the latitudes, it starts blowing with the longitudes. It starts flowing with the longitudes. And such types of jet streams, when they acquire pronounced loops, we refer them as Rossby waves. And when the jet stream becomes weak, it not only acquires Rossby waves, its velocity also decreases. And hence, temporarily it becomes stagnant, maybe for a week, maybe for a few days. And if the loop develops more pronounced, then it will take the shape of the omega letter of Greek. And we refer this as omega block. And this omega block is the one where the warm air is trapped inside the jet stream. And this is the condition which is developed at present in the European countries. And this trapped air is responsible for increasing the temperature of that region. It is something like this. When the jet stream becomes weaker, it will develop the omega block, the pronounced curve. And the warm air, when it enters in that, this warm air, it cannot escape that high pressure lid. It acts like a lid. It cannot escape that. So instead of that, it gets compressed, and this compressed air descends down. And this is something which is adiabatically heated, and this tends to increase the temperature, which in turns are responsible for creating the heat waves or high temperature in the regions of that. So this stagnant jet stream is responsible for developing the heat waves. And hence we say that it is a natural phenomenon associated with the meteorological phenomenon or meteorological aspects and the role of jet stream. And this is how the jet streams and the heating impacts are seen. So the compressed air moves downward, adiabatically heated, and this is called as the omega block or pronounced loop of the jet stream. And this is responsible for the increased temperature. Now, the last discussion of this is, what is the role of climate change in this? Now, we all know that the Earth is experiencing a triple climatic crisis, and within that, one of them is climate change. Now, when you talk about climate change, it is also associated with increasing of the greenhouse gas emission. Now, these greenhouse gas emissions may be carbon dioxide, methane, etc. Now, these greenhouse gas, they have the tendency to absorb the heat, and they are referred as the best absorber of a heat. And they are associated with something called as greenhouse effect. They absorb the temperature and then they re-radiate them back. We refer them as counter radiation. And this counter radiation mechanism is something which is called as greenhouse effect, which is responsible for increasing the temperature. So hence, due to increase of the greenhouse gas, the base temperature itself is increasing. And this base temperature which is increasing is adding more value of temperature, and that is where the heat waves are becoming more dangerous or more strong in that part. So hence we say that the impact of climate change is such that it has increased the frequency, it has increased the intensity, right? And it has also increased the severity of the heat waves there. The base temperature itself is increasing. Now, if you believe in IPCC's report, Intergovernmental Panel on Climate Change, the global temperature has increased tremendously after the pre-industrial phase. And anthropogenic factors are responsible for that. So hence, these greenhouse gases is one of the reasons for making these heat domes often and often to occur, intensity-wise, frequency-wise and all. Now, apart from this, we also know that the Arctic region is warming more than the other part of the earth. So we say that the rate of increasing of the temperature in the Arctic is more than 2 times or 3 times of the other part of the earth. And we refer this as Arctic amplification. And what is the role of Arctic amplification in the heat domes? Now, as the Arctic amplification occurs, the temperature of the polar region is increasing. And as the temperature of the polar region is increasing, so this will have an impact on the average temperature between the Ferrel cell and the polar cell. So this drastically decreases the temperature. The temperature difference between the polar cell and the Ferrel cell decreases very low. And that is where the jet stream often becomes something called as omega block, or it acquires the Rossby waves. And that is where large amount of the area is covered by that stagnant jet stream. And this stagnant jet stream is responsible for creating the scorching heat or scorching temperature in many European countries. Like we have already seen that the fire in the Spain, deaths in European part. So this is all about the heat domes and also the heat waves. And always remember that when you talk about this type of temperature, it is always associated with wet bulb temperature. Now we know that the body's tendency to cool naturally depends on the body's evaporation rate. Now when the moisture in the atmosphere increases, then the body's natural tendency to decrease its heating effect also reduces. So that is why when there is increase of the moisture and when there is increase of the temperature, both are there in the Earth's atmosphere, then when we calculate this temperature, taking moisture and temperature combinedly, we refer that as the wet bulb temperature. Now when the wet bulb temperature is high, say 30 degrees, 31, 32, etc., then the body's natural tendency to cool decreases, because this decreases the rate of evaporation of the body by which it can cool. And this is what exactly happening in the European nations, where they are experiencing extreme health hazards. So this is all about heat domes and the impact of climate change on the heat domes. So by this, I conclude the session. Thank you.